single phase AC circuits, especially MATLAB models, and this class we are going to treat as class 1. Whereas in our previous classes we have already learned about single phase AC system is deriving passive elements like resistor, inductor and capacitor. The voltages and current equations we have already determined in our previous classes. So what is the behavior of inductor, capacitor or resistor when input is AC, and the behavior we have to learn in terms of their waveforms. So for that we are going to take the help of MATLAB. So from basics we know that voltage which is acting as a source is known as instantaneous value of voltage given by the small v is equal to Vm sine omega t, where Vm stands for the maximum value of voltage, and the associated current in resistor is given by Im sine omega t, whereas in inductor you can see Im sine omega t minus pi by 2, and in capacitive circuit you will get the value of current as Im sine omega t plus pi by 2. So when you look into the waveforms of voltage and current, if input voltage is source voltage is deriving resistance, then the voltage in resistance is obtained to be a sinusoidal curve, whereas the current waveform is seems to be in phase with the voltage of the network, where you can see uh, voltage waveform and current waveform, their starting points and ending points, they are terminating at the same level, whereas the amplitude is changed, that is because of the resistor. So here we can say for the resistive circuit, current and voltage are in phase, whereas in inductor you can see uh, waveform which is displaced by a phase difference of pi by 2. So this indicates that one waveform is lagging with the reference waveform by an angle pi by 2, and here we can say current lags voltage, whereas in capacitive circuit you can see the current waveform leads the voltage. So the voltage and current waveforms you can see over here, which are displaced by small v and small I. So these waveforms we should be able to generate in MATLAB. So that is our practical approach. So we can take the help of this first model, where with MATLAB simulation we have to obtain the output voltage across 10 ohm resistor and current through it when an AC input supply of 100 volts and 50 hertz is applied across it. You can see here I have mentioned when an AC input supply of 100 volts. So it is 100 volts, whereas in the practical model I have taken as 141 volts. Why this has happened? Because in the problem, most of the cases, the RMS value of voltage will be given. So here 100 volts represents the RMS value of voltage, and 141 volts represents the peak value of voltage. So the formula for RMS value and peak value can be related by Vm is equal to root 2 Vrms. So if at all you take the value of root 2 and that value if at all multiplied with 100, you're going to get 141 volts. And here you can see the output waveform of voltage and current. Both are in phase, whereas the amplitude waveform is different. So this is one model. In another model, you can see the question is changed to when an AC input supply of peak value 100 volts. So this peak value of 100 volts is given in the problem, and that is why here the voltage value are taking directly as 100 volts, that is the peak value. Okay, and the waveforms of voltage and current, you can see the voltage waveform shown by the blue line and current waveform is shown by the orange line, where you can see current lags voltage. Okay, and in another circuit where you can see input supply of 100 volts peak value is applied to a combination of resistance in series with capacitor. So resistance in series with capacitor, the capacitor value is 1000 UF, indicates microfarad value of capacitor, and all these cases you can see voltages are measured across the elements, whereas current is measured through the element. That is why you can see a voltage source which is taken in the parallel combination of this capacitor, whereas current is taken through the capacitor. And the waveform here you can see I can have a scope of individual voltage, individual current, or I can have the combination of voltage and current with the help of mux arrangement. And here you can see the voltage and current waveforms. So how to get these kind of waveforms in a practical MATLAB model? That is what we are going to see. So for that, I'll initially open this MATLAB command window like this. I'll go to the home model and I'll go for the Simulink model, where Simulink will take some time. So I have to create a black model like this. Okay, and this is untitled. So let me save with some nomenclature. So I have a folder of ECNA models where I'm going to take this one as presentation of AC applied to resistor, inductor and capacitor, and I'll save in my folder like this. So it is not showing a valid option. So what we have to do, again we have to take the look into the gap. You are not supposed to get the gap over here. So this is what I have done. Now you can see the presentation is taken in the name of AC applied to RLC. Okay, so I'll go with the library browser like this. I'll first will go with the Simulink with commonly used block. I can see here a scope is mentioned, so I'll add to this model, and I can have mux and demux. So I'll take the help of mux and I'll add to the model, right? So that is all with this Simulink, and since we are dealing with the circuits, we should go to the Simscape, where you can see you have a subfolders of electrical and foundation library. So I'll go with the foundation library. Do I have anything to take from these things? No, I don't think so. So let me go for this electrical. So under electrical there are subfolders like this. So let me go with the specialized power systems, and here I can see I have fundamental blocks where I have sources. So I require a voltage source. So I'll add to the model. Okay, voltage source is done. Then I'll go with the next thing, that is measuring instruments. What are the measuring instruments? We have to measure current. So I'll take ammeter. I require voltage, so I'll go with the voltmeter. Then again I'll go to the fundamental blocks. This power GUI, this is very important. So this you need to add to the block. Then with the elements. So elements, there are so many. I require resistor, inductor and capacitor. So I'll select this series RLC block and I'll add to the model. Okay, so all these things are added and you need to check whether all these things are obtained or not. Yeah. So here on this presentation, I have all these parameters accumulated at one point. So let me segregate them one by one. Okay, now I have this source voltage. So just I am elaborating the block, and I have a RLC branch. Let us start with first a resistor, and let me take the value of resistor as 10 as it is shown in the PPT. So I will take the value of resistance as 10. Voltage, uh, you can have a voltage of 100 volts peak value, but we are going with the peak value of voltage, and in the problem it is given as 100, that is the RMS value. So 100 multiplied with root 2 will give you the value as 141 volts, and frequency I'm taking as 50. So I'm doing that here. Okay, So a source voltage is connected to the resistor and current is passing through the resistor. So I'm clicking on the current measurements and I'm flipping the block in clockwise such that I can connect the current in this fashion. Okay, so current is also connected. Now you can see I have a mux over here. So mux is a parameter in MATLAB which takes multiple inputs and gives one output, and voltage measurement is given by voltmeter. So I'm going to take the voltage measurement of this parameter in this fashion, that is the voltage across the resistance, and current I'm applying the ammeter to mux as well as voltmeter to mux. Fine. You can reduce the size or increase the size of mux or any other parameter of whatever size you want. So you can see I'm just elaborating the parameters and I'm connecting the scope over here like this, and I'm elaborating the scope block also like this. This also you can show with a major block like this. Now here you have voltage source. So I'll take voltage source. What is the value I've taken? 141 volts maximum value and 50 hertz as the frequency. So this I'm going to elaborate like this of this font of Arial as 24. So this becomes the source representing the block values. Let me club this. Let me keep this block like this. I'm taking another notation of 10 ohms. So 10 ohms. I'm writing like this, and I'm clicking on this, going with the variation of font with 24 Arial, and this I'm keeping over here. Fine. And this represents current measurements. This represents voltage measurements, and this is scope over here. Let me take the stopping time of 0.04. So I have input source voltage applied to 10 ohms, and let me run this block and see what we are going to get over here. So compilation, it will take some time, and finally we are done with the result. Yeah, so you can see over here, this is the output waveform we got over here. For the precise output, I'm selecting this input voltage and current. You can observe the blue line indicates the current and yellow line indicates the voltage. In fact, you can change the configuration parameters manually. Like I'll take it display over here. I'll select on Y label, which is voltage and current. So voltage and current, I'll apply and I'll see. So you can see here on the left on y-axis, voltage and current are mentioned. On x, it is a time scale. So I can minimize this. Yeah. So this is the display of the output. If at all you want to change, you want to get the font size of waveform to get changed, or we can say that the style of the waveform to get changed, then you can go with the tools of accessing and scaling. Here you have many parameters. You can play with all these things. So I'm going with the style. For example, a voltage measurement is taken, or current voltage measurement I'm taking over here, which is indicated by a yellow line. So here I'll select the line and I'll take the font to be 2, and this is yellow only. I can also get any other color. So let me take this color as green. Okay, let me apply, and you can see the waveform is changed to green in color. Okay, again, if at all I want to get the style, for current measurement, so I'll take current measurement. I'll go with 2. Now I'll change the style of the line like with dotted. Okay, and I'll take another color. Let me take the color as purple. Fine. So you can see this is how you can check out the output, or you can glorify the results with the help of the tools which are available on the scope. So this is what we have done with the voltage and current waveform applied to resistor. Okay, individually if at all you want to check the voltage and current, so you can take the help of this scope. So I have selected the scope over here, and I have selected the scope over here. One scope I am giving to the current, one scope I am giving to the voltage. Okay, let me run once again. So it is taking some time for compilation, and check the output result. Now you can see the voltage and current waveform. So you need to change the output waveform because it is a scope of only one variable. So I'll take the voltage measurement. Okay, so the voltage measurement will be of 2 only. Okay, and the configurations you can look into. I have a display. So in display I'll change the thing to voltage, and I'll apply the button like this. So voltage is displayed. Close it. Similarly you can go with the current. So you can check where is the current. Current is over this block. Okay, and this is also shown in green line, but I have to change the value. So I'll go with the style first. So style is purple, so I'll take the purple. Okay, it is a current measurement. Current measurement is made, and tools you can go with the you can go with the view of configuration parameters with the display. Voltage already done, so I'll represent it with current, and I'll apply OK button, and that is done. So you can see the current waveform whose amplitude is changed. It is somewhere between 12.5 to 15, the peak value of current. You need to get the both values, then this is the output of voltage and current. Okay, so that is what we are doing over here. Okay, let me close this. Let me go to the PPT once again and go with this block. Now you can see we have here 100 volts, 1 millihenry, and voltage and current waveforms are displayed by some other waveform notations of blue and orange lines. So is it possible to do this or not? So I'll go with the source here once again. So it's 100 volts, so I'll take 100. I'll apply OK, and here also I'll change 100 volts. Now it's a peak value, and instead of resistance I'll take inductor. You have inductor value of what? Check in the PPT. You have 1 millihenry. Okay, 1 millihenry, so it's a 1 into 10 to the power e to the power minus indicates 10. So I'll apply this. Now you can see the inductor is changed over here. Just change the value like this. Okay, so 1 millihenry is then done over here. So 1 millihenry you can place over here. Okay, now the same thing, voltage and current measurements are there. So run this model. Now check the waveform. Now you see the voltage waveform is ranging from 0 to 100 through the across the inductor, where the current waveform which is showing from minus 300 plus to plus 300 plus, shown by the dotted line. Let me take the configuration parameters and tools also, if at all axis and scale properties are there or not. I have to check. Style, so I'll go with the current measurement, where the line I'm replacing. Okay, so this waveform you can see voltage is starting from 0 and current is starting somewhere at 0.005. So here the current is lagging voltage. Here the current is lagging voltage. Now it is up to you to understand how we got the magnitude value of current, which is more in amplitude, that is 300 above. So you comment in the chat box whether you are able to analyze and synthesize this circuit manually through your theories, whatever you have learned, and check the individual current waveform and voltage waveform, and like the waveform we have presented over here with this circuit, just connect the RC circuit like this, okay, and obtain the output voltage across capacitor and current through it when an AC input supply of peak value 100 volts and 50 hertz is applied to the circuit shown below. So this is a circuit given to you, and this is the output over here. I have not mentioned what is current, what is voltage over here. It is up to you to check out the values theoretically and practically observe in the MATLAB model. So if at all you go on to with MATLAB model, so in this MATLAB model I have to add resistor as well as capacitor. So let me take the resistance value like this of 10 ohms. I'll apply. Okay, I'll just add this over here. So this is the circuit. Check whether you are the same circuit or not. See, 10 ohms is there, 100 volts is there, 50 plus is there, and the MATLAB model, this is capacitor. So go with the capacitor of what value? Check the value. It is 1000 microfarads. UF indicates micro. So what you do here, instead of 1, take 1000 and apply OK, and also change this value. You have 1000 micro, you can indicate with U, and farads with F. So resistance is also there, so you can take resistance value over here. So the value is 10 ohms. So even that we have done over here. Increase the font size. Okay, 10 ohms is connected here. Fine. And here are the measurements like this. Just run like once the circuit. Yeah, the circuit has run successfully. Now you see. Now one waveform is having the peak value which is ranging from below 10 to on the top and below 10 on the bottom, and another waveform is below 30 under negative axis and slight nearer to 30 or above 30 on the positive axis. When you check on with the cycle, you can see for successful of 0.04 cycles, the one waveform is having peak to peak value is somewhat different compared to inductor and compared to the resistor, and whereas the voltage waveform or the waveform which is indicated by this line, which is in purple color, it is somewhat of different. So individually you can check with the help of the voltage waveform. So the voltage is changing from 30 to 30 in this fashion, and current waveform is in this fashion. Now what we have to check whether current leads the voltage or not. Yes, so you can see current is leading the voltage. The green waveform is voltage, the purple waveform is current. So that is how we need to check. So let us go with the model. Yes, so here you can see we have done with these calculations of capacitor in series with resistor supplied to AC input. So that's all for today's class. I hope you like this particular video. Please share among your friends.